Let's look at an example of case 1 for the Routh array. So remember, all non-zero values in column 1 means that we can apply case 1. So let's look at an example characteristic equation here. Delta of s equals s to the fourth plus 4s cubed plus 7s squared plus 8s plus 4. Let's go ahead and construct the Routh array. So in the s to the fourth column, we use 1 because we have 1 times s to the fourth. And then we skip s cubed. So remember, we match 1 to here, we skip the cubed, 2 to here, so we pick 7, and then we skip the 8 and pick the 4. So when we pick the s to the fourth column, we're choosing all the even numbered exponents. Likewise for s to the cubed, we begin with the next part, 4, the second coefficient, and then we choose 8, and because there is no next value here, we choose 0. So we've picked our first 2 rows. Now we go ahead and build the row for s squared. So we calculate the first coefficient, b1, as 28 minus 8 over 4. So we get the 28 because we multiply 4 by 7. That's going to give us 28. So 4 times 7 in this direction, and then we subtract away 1 times 8, and then we divide it by the left-hand column just above the first column in the row just above us. So 28 minus 8 over 4, which is equal to 5. So once we've calculated b1, we calculate b2 in the same way. We're going to calculate 4 times 4 minus 1 times 0 divided by 4. So b2, again, 16, which is 4 times 4, minus 0 over 4, gives me a 4. So now I've calculated the s to the squared entry. So the next step is to calculate the entry for s to the first, or s1. So when we do that, we're going to use the same patterns. 5 times 8 minus 4 times 4 divided by 5 gives us 24 over 5. So I'm going to go ahead and write that just as the value here, because we're going to be able to divide through it later. So S0 we can calculate as 24 over 5 times 4 minus 5 times 0, which is going to be 0, and then divided by 24 times 5. So 24 times 5 times 4 divided by 24 times 5 is just 4. So this system, because all the left-hand column is non-zero, is greater than 0, is stable. So this stable system, you can actually show this by taking delta of s and factoring it in MATLAB or on your calculator to verify that your answer is correct.